Welcome to the project demonstration of overhead lines protection with open circuit faults and short circuits and overload. So here we are going to identify the open circuit fault with help of these R, Y, B lights. By open circuiting these, we are going to switch off the respective phases. So R, Y, B. So here we are going to provide the 230 volts input of 3 phase. So each transformer will step down the 230 volts AC to 12 volts DC. Sorry, 12 volts AC. Why? Because so our system is working using the LM358 comparator, which is non-microcontroller. So whenever we are going to use this LM358 comparator, we need to provide the DC power source only. So for that, so this AC transmission, overhead AC transmission lines, so it consists of 230 volts AC. So each phase to ground is going to be the 230 volts. So for that, we need to use a step down transformer which will step down the 230 volts AC to 12 volts AC, and this regulated power supply board will convert the 12 volts AC to 12 volts pulsating DC. So it consists of 3 stages. One is rectifier and filter and regulator. So after rectifier will get 12 volts pulsating DC, and after capacitor will get 12 volts pure DC voltage, and after this 7805 regulator will get a 5 volts, which is operating voltages of relays and comparators. So here coming to the short circuits, these 3 switches are used to make the short circuit faults by shorting the phases. And next, these are the open circuit faults. So just by disconnecting that, the open circuit error will detected, and based on that, a comparator will switch off the power supply to the respective phases. So for comparator, we are going to use LM358 comparator board. So it consists of reference voltage input with help of these potentiometers, and for overload error creating purpose, we are going to making use of these potentiometers. So when we are increasing the load, then automatically due to the overload, so comparator again will isolate the power supply to the bulbs by disconnecting the supply to this electromagnetic relay. So here we are using 3 electromagnetic relays for each phase. So the flow is 230 volts input, 12 volts AC and 5 volts DC, and after that power supply is given to the comparator as well as relay circuits. So the comparators keep on checking the 3 things. One is open circuits and short circuits and overload. So coming to this relay board, so it consists of 1 transistor. So if you want to switch on the load, then we need to switch on the transistor first, and then relay will get switched on, and then the bulb will get the power supply from this single phasing power supply. You can see this. So let us see the demonstration. So connect the 230 volts input to the each phase. So when we provide the power supply, the system start reading input from the 3 sensing circuits. One is short circuits, open circuits and overload. So all are normal, then the 3 loads will get switched on. Okay, so and coming to the short circuit faults. So when we provide the, and back to the normal again. So RYB, and coming to the open circuit fault also. So again, when it is back to normal again, the respective phases will be resume the power supply to the loads again. And coming to the overload, so when we rotating this, the load is increasing at the reference pin of your LM358. Right, automatically there is a light indication on the LM358 board also. Normal, overload, normal. So in this, we developed this project without using any embedded C language or any microcontroller, which is for programming based. It's going to the pure electrical concept to check the 3 things: short, open and overload indications. So here coming to the transformer ratings, we are using 230 volts to 12 volts AC 3 amp transformers. So the current rating of this transformer is 3 amps. And the relays can control up to maximum 7 amps. So nothing but 1000 watts load can be controlled with help of this electromagnetic relays.